Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go through square and cube roots. So we went through squaring in a previous lesson. If we have something like this, it's read as 1 squared or 1 to the power of 2. It doesn't mean 1 times 2. It means we multiply this number by itself this many times. So 1 squared is just 1 times 1, which is 1. Similarly, 2 squared is 2 times 2, which is 4. 3 squared is 3 times 3, which is 9, and so on. So that's squaring, but what about square rooting? Well, it turns out that square root undoes squaring. So for example, if I take the number 9 and I square it, I get 81. And that's because 9 times 9 is 81. But if I square root 81, I go back to 9. So if you square a number and then square root it, you're back where you started. So squaring and square root undo each other in exactly the same way that, say, multiplication and division undo each other. You know, if you times a number by 4, then divide by 4, you're back where you started. If you square a number and then square root it, you're back where you started. So for square root, we use this symbol here. So we've just shown that the square root of 81 is equal to 9 because 9 squared equals 81. So similarly, up here we found that 1 squared is equal to 1. So that means that the square root of 1 is equal to 1. When I say the square root of 4, I'm saying what number do you times by itself to get 4? And that's 2. 2 squared is 4, so the square root of 4 is 2. And similarly, because 3 squared is 9, the square root of 9 is 3. If I say the square root of 16, I'm saying what number do you square, what number do you multiply itself to get 16? And the answer is 4. Square root of 25 is 5 because 5 squared equals 25. Now, in all of these examples, the answer we got was a whole number, but that's not always the case. So let's say, for example, I wanted to calculate the square root of 20. The problem is 20 is not a perfect square. So the square root of 20 is actually not a whole number. But what I know is that 20 is between 25 and 16. So the square root of 20 will be between this number, square root of 25, and square root of 16. So the square root of 20 will be between 4 and 5. So how I write that mathematically, I write 4 is less than the square root of 20, which is less than 5. Another way to say this, the square root of 20 is between 4 and 5. It's actually about 4.47. So even if we have to square root a number like 20, we can't really find off the top of our head a number that you multiply by itself to get 20. But what we can do is estimate it. So when we're square rooting a number that's not a perfect square, we can find two numbers that it lies between. Alright, so that's all for square roots. Now let's take a look at cube roots. So whereas square roots undo squaring, cube roots undo cubing. So remember, if we have something like this, we say it as 2 cubed. It doesn't mean 2 times 3, it means 2 times by itself 3 times. So 2 cubed is actually 8. So the cubed root of 8, which we write like this, so it's got the same square root symbol, but we have a 3 in there because we're talking cube. The cube root of 8 is saying what number do you times by itself 3 times to get 8? What number do you cube to get 8? And then, of course, the answer there is 2. So as with squaring and square rooting, if you cube a number and then cube root it, you're back to where you started. They undo each other in exactly the same way that multiplication and division undo each other. So if I get something like this, I read it as the cube root of 125. I'm saying what number do you multiply by itself 3 times to get 125? What number do you cube to get 125? And the answer to that is 5, because 5 times 5 times 5 is 125. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.